नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE and NEET. Today I am going to discuss about concentration cell. This topic is divided into two episodes. In episode 1 we are going to discuss about the definition of concentration cell, the type of concentration cell and the condition for spontaneity of a concentration cell. Let us start with the definition of concentration cell. When both the electrodes of a galvanic cell are same, then it is known as concentration cell. So why its name is concentration cell? Because we know that the electrode potential depends on ion concentration. It is possible to construct a galvanic cell from two half cells composed of same material but differing in ion concentrations. Such a cell is called a concentration cell. Let us calculate E naught of a concentration cell. So for any galvanic cell, E naught cell can be written as E naught reduction of cathode minus E naught reduction of anode. So we can write here that left hand side is metal ion half cell and the right hand side is also metal ion half cell, and the metal and metal ion is same. So we can write here that E naught of Fe2 plus ion to Fe minus E naught of Fe2 plus ion to Fe. Since the metal ion and metal both are same, so we can write that E naught cell is equal to 0. And we know that for any galvanic cell, delta G naught of the cell is equal to minus NF E naught of the cell. So from there we can write that delta G naught of the cell is equal to 0 because E naught of the cell is equal to 0. And delta G naught of the cell can be written as minus 2.303 RT log equilibrium constant. Since delta G naught of the cell is equal to 0, from here we can say that equilibrium constant is equal to 1. So let us try to understand the concentration cell. On the left hand side the concentration is 0.01 molar and they are saying that left electrode is anode, and on the right hand side the concentration of iron plus 2 ion is 0.1 molar and it is cathode. So if we write that what is the reaction taking place at anode and cathode, we can write that at anode iron in solid state is converted into iron plus 2 in aqueous state plus 2 electron. At cathode the iron plus 2 ion present in aqueous medium will accept 2 electron to form iron metal in solid state. If I add the reactions taking place at anode and cathode, we can write the 2 electrons on the left hand side and right hand side will cancel out. Iron metal in solid state in left hand side and right hand side will cancel out, but I cannot cancel iron plus 2 in aqueous state because the concentration of iron plus 2 on the right hand side and left hand side will be different. We can write that the reaction quotient Q for this reaction is equal to the concentration of iron plus 2 ion, because this iron plus 2 on right hand side is obtained from anode reaction. So we are writing that concentration of iron plus 2 ion at anode divided by concentration of iron plus 2 ion at cathode. So this is the reaction quotient. We have proved that for a concentration cell, E naught cell is always 0. So by using Nernst equation we can write that EMF of this cell is equal to E naught of the cell will be 0 minus, if the temperature is room temperature, then we can write that 0.0592. The number of electrons participating in this reaction is 2 log reaction quotient, that is concentration of iron plus 2 ion at anode upon concentration of iron 2 plus ion at cathode. So for a concentration cell, the EMF of the cell will be positive when the reaction quotient will be less than 1. So from here in this particular example we can see that the concentration of iron plus 2 at anode compartment is 0.01 and the concentration of iron plus 2 at cathodic compartment is 0.1. So on simplification we are getting this value as 1 by 10. So if we simplify this minus and minus will become plus. So we can write that EMF of the cell is equal to 0.0592 divided by 2 volt, and this value is at 298 Kelvin. what is happening in this concentration cell when the oxidation reaction is taking place at anode, when iron in solid state is converted into iron plus 2 ion by releasing 2 electrons. The concentration of iron plus 2 ion in anodic compartment is increasing with time. So the concentration of iron plus 2 ion will increase, and the concentration of iron plus 2 in the cathodic compartment is going to decrease with time, because there is consumption of iron plus 2 in the cathodic reaction. So we can say that in this concentration cell, the compartment where the metal ion concentration is less is increasing, and the compartment where the metal ion concentration is more is decreasing. So they are trying to make the concentration of iron plus 2 in both compartments equal. When they will be equal, reaction quotient is equal to 1, the cell will stop working. So in this second concentration cell, this is also metal ion half cell, and the metal is silver on both the electrodes, and the metal ion is Ag plus ion. So we can see here that they have mentioned that left hand side is anodic compartment and the right hand side is cathodic compartment. The concentration of Ag plus ion, because it is AgNO3, so the concentration of Ag plus and nitrate ion will be same. The concentration of Ag plus ion on the left hand side is 0.1 molar, and the concentration of Ag plus in cathodic compartment is 1 molar. So again here we can say that the purpose of a concentration cell is to make the concentration of Ag plus ion in both the compartments equal. So when the cell will work, the concentration of Ag plus ion in anodic compartment will increase with time, and the concentration of Ag plus ion in cathodic compartment will decrease with time. Then only they will become equal. So when we write that what is the reaction taking place at anode, we can write that at anode Ag solid is converted into Ag plus ion in aqueous state by releasing 1 electron, and at cathode the Ag plus ion in aqueous state will accept 1 electron and deposit on silver metal. So if we write that what is the overall reaction, we can cancel out the number of electrons on the left hand side and right hand side. We can cancel silver metal on left hand side and right hand side, but we cannot cancel Ag plus ion on left and right because their concentrations are different. And again from here, if I write that what is the reaction quotient, we can write that is equal to the concentration of Ag plus ion in anodic compartment upon concentration of Ag plus ion in cathodic compartment. So Ag plus at anode upon Ag plus ion concentration at cathode. If we put the value here, in anodic compartment the concentration is 0.1 and in cathodic compartment the concentration is 1. So again if we write that what is EMF of this concentration cell, for concentration cell E0 cell is always 0 at room temperature, we can write 0.0592 upon number of electrons 1 log reaction quotient, that is equal to 1 by 10. So again on simplification this minus will become plus. We can write EMF of this concentration cell is equal to 0.0592 volt at room temperature. In this third galvanic cell, on the left hand side hydrogen gas is there, and in aqueous medium H plus ion is there because of HCl. On the right hand side hydrogen gas is there and HCl is there in the solution. So we can say that this electrode is concentration cell because anode and cathode both half cell electrodes are same. So if I write that what is the reaction taking place in anodic compartment, till here we are not able to decide that which electrode will be anode and which will be cathode, but whatever, whenever we write that what is the reaction taking place at anode, it means that hydrogen in gaseous state will oxidize to form 2 times of H plus ion in aqueous state by releasing 2 electrons. So in anodic compartment, since the concentration of H plus ion is increasing, while in cathodic compartment the reverse reaction will take place. 2 times of H plus ion in aqueous state will accept 2 electron to form hydrogen gas. So in cathodic compartment the concentration of H plus ion is going to decrease. If I am assuming that left hand side is anode and the right hand side is cathode, then I can say that in anode the concentration of H plus ion should increase with time, while in cathode the concentration of H plus ion should decrease with time. While in case of pressure of hydrogen gas in anodic compartment, the pressure of hydrogen gas should decrease with time because hydrogen gas is consumed here, while in cathodic compartment the pressure of hydrogen gas should increase with time. So if I write that what is the reaction quotient of this overall reaction, so we can cancel out the electrons, since in this the pressure of hydrogen gas in anodic and cathodic compartment is different and the concentration of H plus ion in anodic and cathodic compartment is different. So because of that we have to write that the reaction quotient for this galvanic cell is equal to the concentration of H plus ion, because the H plus ion on the right hand side is in anodic compartment. So concentration of H plus ion at anodic compartment whole square divided by concentration of H plus ion in cathodic compartment whole square multiplied by the pressure of hydrogen gas in cathodic compartment upon pressure of hydrogen gas in anodic compartment. So this is the value of reaction quotient, and we know that for this concentration cell E naught cell is always 0. So EMF of the cell will be positive when reaction quotient will be less than 1. There are two types of concentration cell. The first one is electrode concentration cell and the second one is electrolyte concentration cell. So what is the difference between electrode concentration cell and electrolyte concentration cell? So let us start with electrode concentration cell. So electrode concentration cell, the electrodes themselves have different concentrations, either because they are gas electrodes operating at different pressures or because they are amalgams, solutions in mercury with different concentrations. So the name electrode concentration cell is related to electrode. So if the gas present at electrode has different pressure, or if the electrode is amalgam and the concentration of amalgam is different, then we'll say that the galvanic cell or the concentration cell is electrode concentration cell. In this example we can see here that if the concentration of HCl, molarity of HCl on the left hand side and the molarity of HCl on the right hand side is equal, if M1 is equal to M2 but the pressure of hydrogen gas on the left hand side is not equal to the pressure of hydrogen gas on the right hand side, but P1 is not equal to P2, then we can say that this is electrode concentration cell. So when the pressure of hydrogen gas at the two electrodes are different but the concentration of H plus ions will be same, then we'll say that it is electrode concentration cell. So for this electrode, again if I write that what is the reaction taking place at anode, so at anode hydrogen in gaseous state will oxidize to form 2 times of H plus ion in aqueous state plus 2 electrons. At cathode 2 times of H plus ion in aqueous state will accept 2 electron to form hydrogen in gaseous state. So if I add these two reactions, the electrons on the left hand side and right hand side will cancel out. Here since the concentration molarity of H plus ion on the left hand side and right hand side is same, so that is also cancel out. So the reaction quotient for this concentration cell is equal to the pressure of hydrogen gas on cathodic compartment upon pressure of hydrogen gas on anodic compartment. Since E naught of this cell is equal to 0, we know that if reaction quotient is less than 1, this galvanic cell will be spontaneous. So we can say that if the pressure of hydrogen gas in cathodic compartment is less than the pressure of hydrogen gas in anodic compartment, then this cell will be spontaneous. And we can see here that when this cell is going to work, since in anodic compartment hydrogen gas is consumed, so the pressure of hydrogen gas is going to decrease with time, and in cathodic compartment the pressure of hydrogen gas will increase with time. So here we are seeing the condition that initially the pressure of hydrogen gas in cathodic compartment is less. So with time the pressure of hydrogen gas in cathodic compartment is going to increase, and the pressure of hydrogen gas is more in anodic compartment initially. So when the cell will work, the pressure of hydrogen gas in anodic compartment is going to decrease. So this is electrode concentration cell. Now let us see electrolyte concentration cell. In electrolyte concentration cell, the electrode compartments are identical except the concentration of electrolytes. For example, here if I am saying that the pressure of hydrogen gas on the left hand side and the pressure of hydrogen gas on the right hand side will be equal if P1 is equal to P2, but the concentration of HCl on the left hand side is not equal to the concentration of HCl on the right hand side. M1 is not equal to M2. The molarity of H plus ion on the left hand side and right hand side is not equal. Then it is known as electrolyte concentration cell. So in this cell, again if we write that what is the reaction taking place at anode, so we can write that at anode hydrogen gas will oxidize to form 2 times of H plus ion in aqueous state plus 2 electron. At cathode, 2 times of H plus ion in aqueous state will accept 2 electron to form hydrogen in gaseous state. If we add and write the overall reaction, the 2 electrons will cancel out. Here the pressure of hydrogen gas on left hand side and right hand side is equal, so that will cancel out. So the reaction quotient is equal to the concentration of H plus ion. Since H plus ion is on right hand side in anodic compartment and left hand side in cathodic compartment, so concentration of H plus ion in anodic compartment whole square upon concentration of H plus ion in cathodic compartment whole square. If we write what is the EMF of this concentration cell, since E naught cell is equal to 0 at room temperature, it is 0.0592 upon number of electrons participating in this overall reaction is 2 log reaction quotient, that is concentration of H plus ion in anodic compartment whole square upon concentration of H plus ion in cathodic compartment whole square. So this 2 and 2 will cancel out. If we further simplify, we can say that EMF of this cell is equal to minus times of 0.0592 log concentration of H plus ion in anodic compartment upon concentration of H plus ion in cathodic compartment. Since this cell is spontaneous when the reaction quotient is less than 1, we can say that when the concentration of H plus ion in anodic compartment is less than concentration of H plus ion in cathodic compartment, then the cell will be spontaneous. So during the working of the cell, what will happen? At anode, oxidation will take place. Due to oxidation, the concentration of H plus ion will increase with time. At cathode, H plus will consume, so at concentration of H plus ion will decrease with time. So here if we are saying that the left hand side electrode is anode and the right hand side electrode is cathode, so during the working of the cell, the concentration of H plus ion in this is going to increase and the concentration of H plus ion in cathodic compartment is going to decrease, and when they will become equal, the cell will stop working. Through the fourth example, let us try to revise the things we have learned in this video. So the left hand side there is chlorine gas whose pressure is 1 bar, and on the right hand side there is chlorine gas whose pressure is also 1 bar. In the solution there is chloride ion in the left hand side as well as right hand side. So both electrodes are gas ion electrodes, and the gas and the ion is same, so it is a concentration cell. The second thing is it is electrode concentration cell or electrolyte concentration cell. So from here we can see that the pressure of chlorine gas at left hand side electrode and right hand side electrode is same. At anode and cathode the pressure is same, so definitely it is not an electrode concentration cell. Since the concentration of Cl minus on the left hand side and the right hand side compartment is different, it is electrolyte concentration cell. So this concentration cell is electrolyte concentration cell. So if I write that what is the reaction taking place at anode oxidation will take place. Cl minus ion in aqueous state will convert into Cl2 gas by releasing 2 electrons. At cathode, Cl2 gas will accept 2 electron to convert into chloride ion in aqueous state. In overall reaction, if we add these reactions, the electrons on the left hand side and right hand side will cancel out. Since the pressure of chlorine gas on left hand side and right hand side is same, that will cancel out. So the reaction quotient of this concentration cell is equal to the concentration of Cl minus. Since the Cl minus on the right hand side is in cathodic compartment and left hand side is in anodic compartment, so we can write that concentration of Cl minus in cathodic ka whole square upon concentration of Cl minus in anodic compartment whole square. We know that E naught cell will be always 0 for a concentration cell, so EMF of this cell will be positive when the reaction quotient will be less than 1. It means that the concentration of Cl minus in cathodic compartment should be less than the concentration of Cl minus in anodic compartment. So here we are saying that the initial concentration of Cl minus in anodic compartment is more than the concentration of Cl minus in cathodic compartment. So from this we can say that X is greater than 1. So the value of X is greater than 1, we can conclude, and during the working of the cell, the concentration of Cl minus ion in anodic compartment is going to decrease. We can see here in the reaction that there is consumption of Cl minus ion with time. So the concentration of Cl minus ion is going to decrease, and in cathodic compartment the concentration of Cl minus ion is going to increase with time, and finally at equilibrium the concentration of Cl minus ion is equal to the concentration of Cl minus ion in both compartments. At that condition the cell will stop working. So I hope that this video is useful to you. In the second episode of concentration cell, we are going to discuss 3 things. The first thing is the concentration cell is used to determine solubility product of a sparingly soluble compound. The second is, do you know a ECG is based on the concept of concentration cell? And the third one is, do you know working of concentration cell is entropy driven process? This third point is asked in JEE Advanced 2022 paper, and it is one of the difficult problem of 2022. So friends, if you are liking our videos, please subscribe and share with your friends. Thank you.